welcome you all in this session of foundation course. So this is the fourth lecture, and in this session we will cover the last topic of the fluid static. So in the fluid static we will cover only two things: that importance of hydrostatic force, that means the hydrostatic force on the plane surface, and hydrostatic force on the curved surface. So today we will discuss the hydrostatic force on the curved surface. So my dear, if you look, one second, if you see that hydrostatic force on the curved surface, so once again, before starting the lecture, there is your this is the IMS features. That means if you join the online program, so if you join the online program, so there are very good advantage. What is that? You get 800-hour live classes with a live interaction, and also there is a theory book, exercise book, which contains 4,000 plus questions and 34 years gate question bank with a video solution. This is very unique features. 38 year, okay, and there is a video solution. That means if you have any difficulty in the question, in that question they provide the video solution. So that is very helpful to you. And also there is a unique feature of the IMS. What is that? 12 personalized one-to-one mentorship. Sometimes a student sometimes student are not able to ask in the question in the classes or class, so they are able to book the my plan session for the corresponding faculty, and the faculty will interact one-to-one. Last but not least, what is that? 130 online test with a video solution of a mock test and many more. If you want to more counseling, if you want that more information about that, you can call directly. This is a toll-free number, that means 966337628 and 771887155588. And there is a very good things, and you have a get many notification and also latest update. So you can join our Telegram group. What is the Telegram group? What is the features in this one? What you have to get advantage? What is that? Schedule for the free YouTube lecture. That means what is the timing? What is their timing, and what is the routine, and what is the course flow for the YouTube lecture? You can also see in the Telegram group lecture PDF. What the lecture will done on today's. Let's suppose today's lecture will done, so that PDF will upload in the Telegram group. And also important updates regarding the seminars, webinar, all the things, and also PSU and other government notification you also get time to time. Expert session of the important topic, expert session on the important topic. If we have a that means a expert session, that means the very good session for the important topic, and daily quiz and many more. Quiz is very important. If you solve quiz regularly, they must have a very good knowledge about that subject. And to join this one, visit this website. Okay, so that is for that one. Okay, now we will start. We will start the hydrostatic force on the curved surface. That is very important. Hydrostatic force on the curved surface. Hydrostatic force on the curved surface. See, my dear. Yes. So first look at this figure. See, there is a difference between the hydrostatic force on the flat surface and hydrostatic force on the curved surface. Different methodology. What is that? In this one, the force is concurrent force system, and that why? Because in the force in each and every point, so each and every point the force will exert. Each and every point the force will exert hydrostatic force, and due to the curvature of the surface, hydrostatic force. Due to the curvature of the surface, hydrostatic force. That means each and every point of the hydrostatic force, each and every point of the pressure force. You can say that each and every point of the pressure force are concurrent at a point, so that each and every point the direction of the forces will change. But in the parallel, that means in the flat surface, the direction of the forces is not changing. Why? Because all are the parallel force diagram. Now, my dear, look this figure. Look at this figure. This is your figure. Let's suppose this is your curved surface. Okay, this is your curved surface. This is your curved surface inside the water, and this curved surface holds the water. Okay. Now, what is that? if you take this curvature, if you take this is your curvature, this is your curved surface, and if the projection of each and every, let's suppose there is a pressure point, there is another pressure point, there is another pressure point on the surface, another pressure point, there is another pressure, there is another pressure, the pressure will vary. Pressure will vary. So each and every point the pressure will vary. And now if you take the projection of this pressure, if you take the projection of this one, if you take the projection, so this is your projection. So this is your what projection? Vertical. This is your horizontal projection above the free surface. So this is your free surface. This is your free surface. So what is the curvature is there? If you project, have here. So if you have a surface, and that surface, if you project vertically up, so what the fluid is contained within this region? What the fluid, hi Sami, what the fluid is contained in this surface up to the free surface, that will define the vertical force. That will define the vertical force. That means, now my dear, the vertical force. So let's suppose my dear, on this surface their force will act. A force is acting on the surface. A force is acting on the surface. So my dear, there is a point where the resultant force will act. Let's suppose this is your resultant force will act at the point, at this point. Okay. Now this resultant force act at a point, and now this resultant force have a two component. Yes or not? This resultant force have a two component. One is your vertically downward. One is your vertically, let's say this is your vertically downward. Other is vertically downward, other is horizontally. So this force have a two component. Yes or not? This force, this resultant force have a two component. This is your vertical force, Fv, and this is your horizontal force, Fh. Now my dear, this vertical force, how to calculate this vertical force? If you take the projection of this surface vertically up, if this projection of the surface vertically up to the free surface, so there must be a region which is contained by this curved surface. There must be a region. There must be a volume. There must be a volume contained by this surface. That means if there's this surface, and if this surface will project vertically up, projection, it is a vertically up, so there must be a region in which the imaginary fluid will present. If the fluid will present, that means this surface had hold some fluid, so the fluid will present vertically up. So that vertically up is your vertical force. This vertical force, that means this region, where is the, from this which center, this is the vertical force, so this force will pass at a some location, some point. Where it will pass? It will pass at the centroid of this volume. Centroid at this volume. So see my dear, resultant force pass with another point, that means a center of pressure, but the vertical force will pass of the centroid of this volume. That means centroid. That means if the volume is contained, so what is the volume of this region? That what is the volume of this region, and at which point the center of the volume will lie, along that point the vertical force will pass. Now if you calculate the horizontal force, so you project a vertical projection. So take each and every point a vertical projection. So this is your vertical projection. This is your vertical projection. So this is your vertical projection. Each and every point there is a fluid and there is a pressure distribution. Why? Because if there is a vertical projection, so at this point low pressure is there, and at this point there is a high pressure is there. So there must be a pressure distribution. So this is your pressure distribution. This is your pressure distribution. This is your pressure distribution on the surface. So these are so resultant of this pressure pressure force is your horizontal force, and this horizontal force again, it is your center of the volume. That means, what is the volume? That means, if this is the pressure diagram, this is your pressure diagram, yes or not? This is your pressure diagram horizontally. So that pressure diagram, what is the center of that pressure diagram? What is the center of that pressure diagram? At that point, this horizontal force will pass. So at this component, there is a horizontal force and there is a vertical force. Vertical force will pass from the centroid of the volume contained by the curved surface, and the horizontal force will pass at the pressure centroid of the volume of the pressure prism. Centroid of the volume of the pressure prism. Centroid of the volume of the pressure prism, or Cp of the resultant force, Cp of the hydrostatic force, horizontal direction, Cp of the area of that. What is the area? There is a plane area. If this is a volumetric image, if you project the line view, so there must be area. So the areas, so there must be area. So we have to find the center of pressure also with the help of Yp, like that, Yp. From that one, you also find Yp is equal to Y bar plus Ix a Y bar. You can also find the center of pressure where it will act. Okay, or also you take the centroid of this volume, also the same point. So these are the projection. Now, if we take this is your not a plane view. This is a volumetric 3D view. This is your 3D view. Now, if you take the 2D view, so what is the resultant of that? What is the conclusion? What is the conclusion? There are two conclusions, beta. First conclusion is that, see my dear, first conclusion is that from this two diagram, first conclusion is that resultant horizontal force component, that means there is a horizontal component. So the resultant of horizontal, so what is the resultant is there, and from that resultant the horizontal component, that means, see my dear, see, this is your, let's suppose this is your force will apply, this force will apply Fr, resultant force. So this resultant force have a component horizontal and vertical. So this is your horizontal force and this is your vertical force. So resultant horizontal force component, this is your resultant horizontal force component, resultant horizontal force component, this is a resultant horizontal force component acting on the plate is equal to the, very important, is equal to the resultant force of the pressure loading acting on the area vertical projection. Vertical projection. That means if you take the vertical projection of this area, if you take the vertical projection, so on that particular projection, that means resultant force of the pressure loading acting on the area on a vertical projection of the plate. That means if you find this horizontal, so this horizontal force will act on the area which is a vertical projection of the curved surface. Okay, now so you can find like that, FH, you can find two method. FH, horizontal force, is equal to, what is that beta? Rho g, this is the height, vertical height from the free surface, this is the vertical height from the free surface to the center of the CG of the plane surface into projected area. Projected area you have to find, or you have to find from the pressure prism, what is that? The horizontal force is equal to volume of the pressure prism. Pressure prism, volume of the pressure, from this method or this method. This is called formula method, and this is your projection method. You can find the horizontal force. Where it will act at the center of pressure, or it will act at Cp, or in this sense it will act at Cv. That means what is the volume of this pressure prism? The center of the volume, Cg of this volume is Cv. Cp is the center of pressure. Cv is the center of the Cg of this volume. So hydrostatic force is equal to volume. When we have to find the horizontal force, this horizontal force is equal to volume of the pressure prism. So where it will act? It will act Cg of the volume prism. And this is also, we have to form formula method. This is what? Centroidal pressure into the area of the plane. And it will act at the center of pressure. And this center of pressure, or ACV, will lie between the lower portion of the surface. Now, second one, if you find the vertical, so if you find the vertical, this is your horizontal. If you find the vertical, so if you find the vertical force, what is that, my dear? Resultant vertical force acting on the plate is equivalent to weight of the volume of the liquid acting above the plate. This is very important. What this is, that means, what is the consequence of the vertical force? The consequence of the vertical force, it is the weight. It is the weight of the fluid which is contained by this curved surface up to the free surface. I repeat, this is your weight. This force is equivalent to the weight of which one? The weight of the fluid which is contained by this curved surface up to the free surface. So it is a weight, so it will act as the center of gravity, Cg of this weight. Okay? Now, so this will be vertical force is equal to the weight of the fluid up to the free surface. And it will act as the Cg. It will act as the Cg. Why? Because weight will act as Cg. So it will act, horizontal force act as the Cp, vertical force act at a Cg. Clear? Now, my dear, if you look this diagram, so what is that? We are showing a edge view. So this is your curvature. Any curvature is there. Okay, this is your any curvature, my dear. One second. Okay, this is your any curvature. Any curvature is there. Now, my dear, see this one. This curvature is little bit far below that free surface. What happened? If you find so this curvature, this is your fluid. In this curvature, there is a fluid. So this fluid will act. Let's suppose the fluid will act. So what is that, beta? There is a pressure will vary. So at this point, what is the pressure? This height. Let's suppose this height. Let's suppose, my dear, this height is your H1. This height is your H1. This height is your H2. This height is your H2. Let's suppose this height is your H2. Okay. This height is your H2. Now, my dear, if this height H2, so from this height, if this is your point, here tangent is passed, so this is your A. Pressure will act. At this point, pressure will act. What is the pressure? Rho G H1. And at this point, the pressure will act equivalent to rho G H2. So H2 is higher than H1. So here it is higher pressure. Okay. Now my dear, if you join, so this is your pressure variation, yes or not? This is your pressure variation. This is your pressure variation. That means each and every point perpendicular to that surface, this your pressure will vary. Now, so there must be a resultant force. There must be a resultant force. There must be a resultant force. There must be a resultant force will act. So let's suppose there is a resultant force will act at any point. Let's suppose this is your resultant force, resultant hydrostatic force, resultant hydrostatic force Fr. Now this Fr, resultant hydrostatic force, this Fr have a two component. One is your horizontal component, other one is your vertical component. Yes or not? One is your horizontal component, other one is vertical component. So if you find the horizontal component, take a projection in a vertical direction. Take a projection, that means this surface and this surface, you take the projection of this surface in a vertical direction. That means a curved surface projected onto the vertical plane, and then at that point, what is the force will act? Why this is circle? Why? Because it is into. So here horizontal force will act FH. So this is your FH. This is your FH. Okay. Now, how to find the vertical force component? How to find this vertical force component, my dear? So this vertical force component, if you find, so we already know that, sir, if you find the vertical component, you have to project this curved surface up to the free surface. We have to project this curved surface, projection of this curved surface up to the free surface vertically. That means if this is our curved surface, let's suppose curve A and B, this curve A and B. So this curve A and B will project, this is your free surface. This is your free surface. So this curve will project. This curve will project up to the free surface. Up to the free surface. This curve also at this point will project at this surface. So my dear, what is the weight? What is the weight? That means what is the vertical force? The vertical force is equal to weight of the fluid which is contained, which is holding, which are supporting by this curved surface up to the free surface. Up to the free surface. So if it is up to the free surface, so my dear, we have to calculate the volume. We have to calculate the volume of this total element. So it will combined with the two types. One is the rectangle, other is the, let's suppose this is a semicircle. So these are the two things. So how to calculate? Find first weight of this one, second weight of this one, equal to what? Vertical force. So the net vertical force is equal to W1 plus W2, and it will act downward. It will act downward. What is a W1, my dear? What is W1? Density into G into volume V1 plus volume of V2. So how to calculate volume of V1? Let's suppose my dear, this is your rectangle. So let's suppose this is your H height. How to calculate this is? Let's suppose this is my dear. One second. Let's suppose this is this one. Let's suppose this 3 into this one. Let's suppose this is your A, B. Let's suppose this is your H1. And let's suppose this is your radius. Let's suppose this is a semicircle. So this is your radius R. This is your radius R. So what is the volume of this one? And let's suppose its width. Its width is W. Yeah, its width is B. So what is the volume? The volume of this one is your H1 into R into B. This is your volume of this one. So if you put this value here, now what is the volume of V2? So V2 is what? Quarter circle. So what is the area of this quarter circle? First calculate area, pi by 4 and R square. This is your area of quarter circle, multiply with the B. So this is your volume of this quarter circle. Put here density of the fluid G, volume it is equal to H1 R square, R into B, R into B, R into B, correct? R into B plus pi by 4 R square into B. So this is your net vertical force. This is your net vertical force. And what is the horizontal force? You take the projection, and horizontal force you can calculate by two methods. First is the formula method. What is that? Horizontal force is equal to rho g h bar into area projected. Rho g you have. What is the h bar? H bar, it is your, if this is your vertical projection, so take the, let's suppose this vertical projection, this projection, let's suppose this is your, this one, this is your vertical projection. So this is your vertical projection. So this vertical projection is also R, yes or not? This vertical projection is R, total is the radius. So R, so vertical projection it is your R, let's suppose. Now let's suppose there is H1. So what is the CG of this from the free surface? This H bar is the CG. This H bar is the CG of a vertical projection from the free surface. So this H bar is equal to, so what is the CG of this one? This CG of this one here, and that is your R by 2. So this is your R by 2. So H1 plus R by 2 is H bar. So what is your H bar? H1 plus R by 2. So put H1 plus R by 2, and what is the projected area? What is the projected area? This is your projected area. So projected area is your rectangle. So projected area is your rectangle. So this is your projected area. So what is the area of this one? Projected area. This is your width B, and this height is R. This height is R and width is B. So what is the projected area? So what is the value here? Rho G. What is H bar? H1 plus R by 2 into what is the projected area? H into B, R into B. That's it. This is your horizontal force. This is your horizontal force. Like that, you have to calculate all the things. Now, my dear, think the another situation. What is that? See this one. Let's suppose there is this is your one situation is there, in which this is your surface. This is your surface. Okay, this surface is holds the fluid. This surface is holds the fluid. So on this surface, my dear, on this surface, what is your horizontal force? What is the horizontal force on this surface? So if you take the, so this is your free surface, mind it, this is your free surface. So if this is our surface, my dear, see this one. If this is our surface, okay, no problem. So we take the horizontal projection. So this is our vertical projection. If you find the horizontal force, take this surface of a vertical projection, and from here, this is at a free surface, and this is a point. Now, if you have this length and you have an angle theta, let's suppose this angle is vertical projection area. Here it is given theta. It is not given here. Here it is given theta value. Here it is given theta value. So you can easily calculate this. Let's suppose this length L it is given. this length L it is given. So what is this length, beta? What is this length? Please tell me. What is this length? What is this length? L sine theta. What is this length? L sine theta. So this L sine theta, your height it is given. So my dear, if we calculate the hydrostatic force, let's suppose its width is B. This plate have a width B. Now my dear, we have to calculate the horizontal force by two methods. First method is what? FH. If you calculate FH, that FH is equal to what, beta? Density of the fluid into G, and what is the, and this will act, this is centroidal pressure, it will act at a vertical projection CG. So what is the CG? This L, this height, this is your height, so divided by 2. So L sine theta divided by 2. This is your CG, H bar, into vertical projection. So this vertical projection is what? Let's suppose this is your vertical projection. So this height is L, width is B. So LB sine theta. That's it. So this is your horizontal. Or you can calculate hydrostatic force FH is equal to volume of this triangle. So what is the volume? First area half. And what is the pressure at here? Rho. What is the pressure at this point? Rho G into the height L sine theta. This is the pressure. So half into base. What is the base? Rho G L sine theta, base into the height. Height is what, beta? L sine theta. So this is your area, half base into height into the width. Why? Because this is the volume. So don't forget width V. So this is what, beta? Half rho G L square sine square theta into B. This is your horizontal force. You can calculate both of these one. So here it is same thing. Let's see. Half rho G L square sine square theta. Same result. See the beauty. Same result you have to. So this method is called formula method. This method is called projection method. Clear na? And where it will act? It will act at the CG of this triangle. CG of this triangle. So what is the CG of the triangle? Let's suppose this is L. So the CG from the base, it is what, beta? H by 3. It is H by 3. So L sine theta divided by 3, it will act from the base. Clear? Now, how to calculate the vertical force then now? You have to take this point A up to the free surface, and this is already the free surface. So what is the volume, what is the weight contained within this one? That is your vertical force. That means the vertical force is equal to volume contained within this region. What is the volume of this one? Simply, you have to get this length it is given. So first calculate the area, multiply with the V. So what is the, so this is a volume, not it is a weight. It is a weight. And weight is equal to what, beta? Rho G into volume. Now what is the volume of this one? The volume of this one, this volume. What is the volume? First calculate area, half into, take anything, base L sine theta. And what is the, this theta? This is the height and this is base. Base is what? L cos theta. L cos theta. So this is half base into height, okay, into the width B. So this is what? Half L square B sine square theta. This is your volume. Now put here, so this is your vertical force, rho G by half L square B sine square theta. This is your vertical force. This is your vertical force, and it will pass the CG of this surface. So this it will pass CG. So from this is your base, this is your base, this is your base. So from this one, if you calculate from this one, it will pass. So where it will pass from this one, also this is triangle, so this will pass, this is total height is what? L cos theta. So this is your, this will pass L cos theta by 3. So it will pass L cos theta by 3. Clear? So all the things you have to calculate. Now think this situation. What is happening in this situation? In this situation, see, this is your curve. ADC. ADC is your curve. Okay? ADC is your curve, my dear. Now, ADC is your curve. One second. Okay. One second, beta. One second. Now see this figure. This is your ADC. This is a kind of the surface is there. Now the free surface is there. This is your free surface. This is your free surface, my dear. Now we have to calculate the resultant hydrostatic force by this curved surface AD. Resultant hydrostatic. So for the calculation of resultant hydrostatic force, we have to calculate horizontal and vertical. Now let's suppose there is any, so here from here to here the pressure is varying. So at any point, let's suppose this is your point P. At this point, this resultant force is passing. Yes or no? This resultant force is passing. Now at this point, there is one of this one vertical component and there is one is your horizontal component. Yes or not? Now if you find the vertical component, what you have to do? This is your curvature. This is your curvature, my dear. Now see this one. This is your curvature. So if this point will take the projection of the free surface, so and this point is taking the free surface, but you are saying that you think that ki sir, here there is no any water. Water is this side. How to project? How to create a free surface? So this is called imaginary free surface. That means you have to take this D point. So you have to extend this line vertically up to this one. D point extend, A point extend. Now what is the volume content? What is the volume content above this imaginary fluid? So this is what, beta? This is your imaginary fluid column. Imaginary fluid column. Now how to find this volume? So what is the vertical force? This vertical force, what is that? This vertical force? This vertical force is weight of the fluid which is imaginary content by this curvature up to the free surface. Up to the free surface. So how to calculate the weight of this one? And weight is what, beta? Rho g into volume of this fluid element, fluid column, volume of this, what that means the volume of A, D, C, B, A. A, D, C, B, A. This volume. How to calculate this volume? Please tell me. How to calculate this volume? Please tell me. How to calculate this volume? Please tell me. Simple. What is that? You calculate this total volume of this. Width is same. Width is same. Width is same. All this width is same. So first you have to calculate the total volume. That means volume of BCEA. So volume of BCEA. So how to calculate volume of BCEA? This height you have. How much this height? It is given. Let's suppose this is height H. So this H into, let's suppose this is same quarter circle and this is your center. So this is your radius. So H into R is the H into R, and let's suppose width is B. So what is the total volume? BCEA. So total volume minus volume of this semicircle, is your volume of BCDA. Yes or not, please? What is the volume of this part? The volume of the total BCEA minus volume of this quarter circle DAED. If you subtract, the remaining part is the volume of this one, simply. So this is a vertical force. This is a vertical force. Now, this vertical force, where it will pass? Where it will pass the CG of this semicircle. CG of this circle. So what is the CG of the circle, beta? We know that from the base, this is your base. So from the base, it will pass 4r by 3 pi. It will pass 4r by 3 pi. What is r? This is or r. So it will pass 4r by 3 pi from the base to the left side. It will pass, this vertical force will pass, and the vertical force will pass the CG of this imaginary fluid, and it will be 4r by 3 pi from the base. Clear? Now, how to calculate the horizontal force then now? See, we are bothering about this horizontal force. How to calculate horizontal force? We have to take the vertical projection. Let's suppose this is your vertical projection. We have to calculate by the pressure method. So these are the, let's suppose this is your vertical projection, my dear. This is your vertical projection. This is your vertical projection, yes or not? This is your vertical projection, my dear. This vertical projection, this hydrostatic, the horizontal hydrostatic force will act. What is the value of this one? What is the value of this one, beta? Rho g h bar into area projected or volume of this trapezium, yes or not? Volume of this trapezium. What is the volume of this trapezium, beta? Volume of this trapezium, that means this one. So how to, let's suppose this height it is given h1, this to this height it is given h1. Now if this total height is h, so what is the pressure here? Rho g h. What is the pressure here? Rho g h1. So you have this pressure, you have this pressure. Now what is the difference in between this length? H minus h1. So this gap is h minus h1. Now my dear, calculate the area. What is the area of this trapezium? Half sum of both height. This means rho g h1 plus rho g h. So this is your area. This is half this plus this into this gap. So what is the gap? H minus h1. So this is area into, let's suppose the width is b. So this is your volume. So this volume is your hydrostatic force. Simple. This volume is your hydrostatic force, horizontal hydrostatic force. Where it will act? It will act as the where it will act? It will act at the CG. That means if this is how much height? This height is your what? H minus h1. So it will act as h minus h1 by 2 and plus this height. H minus h1 by 2 plus this height. That means it will act, this horizontal force will act, my dear. This horizontal force will act. It is your total here h1 plus what is total? H minus h1 divided by 2. It will act. Simple. Clear now? This is clear? This is clear. Now, if it is clear, then there is another concept on the curved surface. Let's suppose, my dear, this is your pressurized tank. That means there is a tank. This is your tank. This is your tank, my dear. This is your tank. This is your tank. Okay. Let's suppose this is your tank. Okay, and there is a curved surface. This is your curved surface. This is your curved surface. This is your curved surface. Let's suppose. Okay, this is your curved surface. And this is your pressurized tank. That means there is a pressurized fluid in the chamber. Now, if we calculate the vertical force, horizontal force is okay. Horizontal force, you have to take the projection, calculate it, no problem. But if you calculate the vertical force, how to calculate? How to calculate? Why? Because, how to calculate? Why? Because there is no any free surface. It is a pressurized. This have a no free surface. If there is like that, see the difference. If this is your curvature is there, and there is a fluid. This is your fluid. And if this is your free surface, you take this curvature. So this is your free surface. Let's suppose, so you take the projection of this one. So what is the fluid will present the weight? That is your vertical force. Why? Because this is your free surface. So how to calculate? You draw, this is your line. So calculate the total volume of this rectangle minus the volume of this quarter circle or volume of this one. So that is your volume of this. But here, here it is not a free surface. Very important. This is not the free surface. This is not a free surface. If it is not a free surface, how to calculate? Now, my dear, if this point have a pressure at any mechanism, if you calculate the point of at this point the pressure, let's suppose at this point the pressure P1. So P1 is equal to what is that? Density of this fluid rho g, and let's suppose there is imaginary height. Let's suppose there is a Z1. So what is Z1? Z1 is equal to P1 by rho g. Now, from this point, you extend up to this Z1. And where it will meet, draw a horizontal line. That is your imaginary free surface. Clear? That is your imaginary free surface. I am telling you very important things. Here, this is different, this is different. This is a free surface, but this is a free surface. It is not a free surface. So at anyhow, if you calculate the free surface at this point, extend up to the free surface, what is the volume contained within this region? Now extend this one. Why? Because this is your imaginary free surface. See, this is your imaginary free surface. So if you extend this one, now what is the volume of this one? That is your what? Vertical force. So how to calculate? Calculate this total volume. Calculate this total volume. This total volume you have to calculate. Subtract this volume. That is your volume. Now, so what is the direction of this one? What is the direction of this one? The direction is upward. The direction it is upward. Why? Because see, this is your resultant direction force. Force F. So it have a two component. One is the vertical, other is the horizontal. So it will act in a vertical direction. So the vertical force is equal to weight of the fluid element, but it act at a upward direction. Clear? This is clear? This is clear. Now same thing is that if this is your pressurized surface, same thing. If this is your pressurized surface, and let's suppose this is your surface. This is your surface. This one is closed surface. Is your closed surface, and there is a curved surface. Is that? This is your curved surface. Clear? Na? This is your curved surface. This is your curved surface. Now, so if this is your pressurized surface, at anyhow, if you calculate the pressure at this point, you calculate the pressure at this point. Why? Because this is not a free surface. My dear, this is not a free surface. Not free surface. Free. This is not a free surface. So, what you have to do? P pressure. So, we know that P is equal to rho g h. So, h is equal to P by rho g. Now, my dear, from this point, you move P by rho g same horizontal, this is a horizontal line, this is a horizontal line, so same pressure is there. Move P by rho g. Now you have to draw an imaginary line. You have to draw so this is your imaginary free surface concept. This is very important. This is called imaginary free concept. Only the problem is why this imaginary, why we have to bothering about this finding the imaginary surface. Why? Because there is no free surface. If there is a free surface, if let's suppose this is a free surface, if this is a free surface, so extend this point up to the free surface. This is already free surface. What is this volume? What is this volume? What is this volume? That is your weight. What is this volume? That means what? How calculate the volume of this one? Calculate the volume of this one. Multiply with rho g. That is your vertical force. But it is a pressurized container. So you have to calculate. So equivalent height concept is there. So if at anyhow, if you find the pressure P in the question, it is a clue, it is a given, or any type of arrangement it is given. So if you find the pressure P, you extend up to the free surface. H height you have, P you have, D, rho is this fluid into G. Find H value, extend this point up to H, and find the free surface. Get the now how to calculate then vertical force? So vertical force here is weight of this one and weight of this one, W1 and W2. Clear now? What is the W1? If this height is there and this is radius R, let's suppose. So H into R into width. H rho g is there. Now rho g into volume. What is the volume? R. H into B. B is the width. Plus what is the volume of this semicircle? Pi by 4 R square is the area into width B. This sort of vertical force. And in this case, what is the direction of this vertical force? So there is a resultant force, my dear. So this resultant force have a two component. First is this vertical and this is horizontal. So in this case, vertical force is downward. But in this case, vertical force is upward. Clear? This is clear or not? Please tell me. This is clear or not, my dear? Please tell me. This is clear or not? If it is clear, then we have to go to the problem. What is that? See this problem. See this problem, beta. What is that problem? A semicircular plate of, in figure, 4 meter long. Long, that means this is your width. This is your width is given, B. Perpendicular to this. That means this B it is given. Okay. This plate, okay. Width it is given. Acts as a gate. So it's act as a gate. It's act as a gate. Right? In a canal. Determine the resultant force that water exerts on the plate and then find the component of a reaction at the hinge point B and at the smooth support A. Neglect the weight of the plate. Neglect the weight of the plate. That means at this point, see, this is our fluid. This is our plate, and at this side there is a fluid. So this plate is trying to freely move at this hinge point. So what is the reaction at hinge point and what is the force will applied at point A, number second, and what is the resultant hydrostatic force? Okay, let's start. Now, my dear, so if you find the horizontal force, how to find the horizontal force, my dear, then? How to find the horizontal force, my dear, then? Horizontal force will find as like that. See, okay, see, I have a time little bit, no problem. Horizontal force. So if we draw, so if you find this, see, this point lie as a free surface. It is at a free surface. So there is no concept of imaginary free surface. Now, this if you find the horizontal force, see, this point, all the points, the hydrostatic force will act, and all the hydrostatic force will act as a horizontal force and a vertical force. Now, my dear, let's suppose there is any horizontal force, net horizontal force will pass. How to define horizontal? If you calculate the horizontal force, that horizontal force is your vertical projection of this curved surface. This horizontal force is what? Vertical projection of this curved surface. So you have to take the vertical projection. You have to take the vertical projection. So vertical projection. So this is your vertical projection, my dear. This is your vertical projection. Clear? This is your vertical projection. Now, my dear, at this point there is no gauge pressure. Gauge pressure is 0, and at this point, what is this total height is how much? 6 meter. Mind it, and the width it is your 4. Width it is given 4 meter width it is given. Now at this point the pressure is 0, and at this point the pressure is maximum. So there must be a pressure variation. There must be a pressure variation, my dear. So there must be a pressure variation. There must be a pressure variation. Yes or not? There must be a pressure variation. There must be a pressure variation. And now, my dear, fluid is this side. So hydrostatic force will act in the right side direction. Hydrostatic force will act in the right side direction. So right side direction, hydrostatic force will act. Right side direction, hydrostatic force will act. So this is your pressure triangle. This is your pressure triangle. Now, my dear, at this point there is any CG. This is, let's suppose there is a CG at this point. C. There is a point C. CG is there. Now, let's suppose this is a free surface A, and this is B. Now, intensity of hydrostatic force is larger in between C and D. So there must be a point where it will pass. The net hydrostatic force will pass at this point. Let's suppose. So this is a net hydrostatic force. Horizontal hydrostatic force will pass. Let's suppose. Okay. So this is your FH. This is your FH. Hydrostatic horizontal force. How to find this FH? Two method. Simple method is what? Area. Find the volume of this triangle. Find the volume of that triangle. So F is what? Area of this triangle is what, beta? So what is the pressure here? What is the pressure? Rho G into 6 meter 3. So this is your pressure. So half. Base is what, beta? Rho G into 6. This is your base. Into height is what? Again 6. So this is your area into width is 4. So this is your hydrostatic force. FH. Volume. This is your hydrostatic force. So if you calculate this one, this is your 706.32 kilonewton. Okay. Where it will act? It will act as a CG of this pressure triangle. So where is the CG of this pressure triangle? It is from base. It is your h by 3. What is h? 6. So 6 by 3. 6 by 3 is 2 meter. So it will act at a 2 meter. Now, so this is a horizontal force. Now, what is the vertical force, my dear? Vertical force, you have to take this projection up to the free surface. And this is also a free surface. So what is the volume of the fluid this fluid will contain? There is no any fluid, but this is an imaginary fluid is there. That volume, if you calculate, that is your vertical force. So what is the vertical force, my dear, then? Vertical force is the weight of this in this region. So weight is what, beta? Rho G into volume. What is the volume of this semicircle? Volume of this semicircle, beta? Rho G. What is the area? What is the area, my dear? Pi by 4 into 3 square. So this is your area into width. Width, it is your 4 meter. So if you calculate this one, this is your vertical force. How much it is? It is your 176.68 pi kilonewton. Where it will pass? From where it will pass, beta? It will pass at the CG of this volume. CG of this volume from the base. How much it is? It is your 4r by 3 pi. We know that. It is your 4r by 3 pi. We know that. So this is your 4r by 3 pi. So from here it will pass 4r by 3 pi. Now, my dear, this vertical force is upward direction. Why? Because here we have take a resultant force. So resultant force at this point, vertical is downward. Here we take a resultant force, vertical is upward. So this vertical upward is higher than this vertical upward. So net it is your upward direction. So net it is your upward direction. So this is your FV, and FV will pass at a distance. At this distance is what? 4r by 3 pi. 4r by 3 pi. So 4r by 3 pi, if you calculate 4r is your 3 divided by 3 pi. So 3 cancel. That means 4 by pi meter from the base to the right side. So FH you have, FV you have, all the value you have, this you have. Now we have to draw a free, so what FV, FH, so we have to find the resultant force FR, a square root it is this one. That means FH square plus FV square. If you put this value, the value it is, just to check the answer, 898 kilonewton. Clear? 898 kilonewton. Now my dear, now we have to calculate the reaction at point A and B. So if you calculate the reaction at point A and B, we have to draw the free body diagram. What is that? Let's suppose this is a diagram. Let's suppose there is a free body diagram is what? From here, see, this is very important thing now. Now this is a free body diagram. Let's suppose this is a free body diagram. So from here, there is a vertical force will pass. 1 second. Here, from here, there is a vertical force. This is a vertical force. Here, there is a horizontal force. Here, it is a horizontal force. Okay. So this is FH. Here, let's suppose there is a reaction. FA will act. Why? Because this water will try to push this gate on the wall. So wall will exert a force in this direction. So this is a force by the wall. Hinge, see, hinge, so let's suppose in hinge, at hinge there are a reaction, there is no any moment. At the hinge there is no any moment. So in this direction, let's suppose vertical force downward and there is a horizontal force. Let's suppose this is your hinge, at the force at the hinge. So let's suppose this is your Bx and By. Let's suppose this is your Bx and By. So let's suppose this is your Bx and By, and this is your Fa, this is your Fv, this is your Fh. Is there any force other than that? No. That means this, if you take this, now we have to find all the forces we have to find. This distance we have, 4r by 3 pi. This distance we have h by 3. Now we have to apply the static equilibrium condition. What is that? Let's suppose this is your x-axis, this is your y-axis. So what is that? Summation of all the force in x direction is equal to 0, and we have to take in the x direction it is positive. First equation. Second one, summation of all the forces in y direction it is 0, and we have to take upward as a positive. Third one, summation of all the moment, we have to take a moment B point. Why? Because moment at B 0 is equal to 0. Summation of all the moment at point B is equal to 0, and we have to take the clockwise moment is positive. So these are the three equations. Apply these three equations, find the each and every value. Find each and every value. So we have to write, this is the simple now, simple question is that. So the value it is By, we have to write By value it is your 5 kilonewton. Now the task is school level mathematics, school level mechanics. Okay. Now Fa is your 353 kilonewton. Okay. Now Bx is your 353 kilonewton. That's it. This is your answer. Clear? So I hope you enjoy this lecture. So in this lecture we cover the curved surface, and these are the basic question, and that question is very good question, all the component reaction we have. Okay. We have two more question, but due to the time constraint, this is the 1 hour session. So I will stop and end it here. Up to that, thank you. Bye-bye.